Download this code from codegive.com, link in the description below. Don't make this clean architecture packaging mistake, the modularity illusion. Clean architecture aims to create maintainable, testable, and independent software. A crucial, yet often overlooked, aspect is how you package your code. While you might meticulously follow the layers, entities, use cases, interface adapters, frameworks and drivers, in your code organization, a poor packaging strategy can completely undermine the benefits of clean architecture, leading to a modularity illusion. This tutorial will delve into this packaging mistake, illustrate it with a real-world example, and provide practical guidance on how to avoid it. The problem: packaging by layer versus packaging by feature/component. The common, and often flawed, initial approach is to package your code strictly by layer. Why this approach is a mistake, despite seeming logically organized: horizontal coupling changes to a single feature, example user management, require touching multiple packages, entities, USECSs, interface adapters, frameworks and drivers. This defeats the purpose of modularity. Every time you add a field to user.java, you may need to modify the create user use case, user controller, and potentially even the database repository. This is tight coupling across layers for a single feature. Reduced testability. Testing a single feature now involves setting up dependencies across multiple packages. The isolated testability of a single, coherent module is diminished. You can't easily test the user creation functionality without pulling in components from all four layers. Deployment challenges. Deploying changes related to a specific feature becomes difficult and risky. You can't deploy just the user management piece, you have to deploy the entire application or large chunks of it. This leads to increased downtime and risk. Code bloat and tangled dependencies. Over time, this approach leads to large, monolithic packages with numerous classes that become difficult to navigate and maintain. The dependencies become a tangled web, making it hard to reason about the system and introduce new features. Violation of the Common Closure Principle, CCP. The CCP from Robert C. Martin, Uncle Bob, states that classes that change together belong together. In this layer-centric approach, classes that change together, related to a single feature, are scattered across different packages. The modularity illusion. This approach appears to be modular because the code is divided into layers. However, true modularity is about isolating features or components from each other. In this case, the tight horizontal coupling creates a modularity illusion, where the system looks modular on the surface but lacks true independence and maintainability. The solution: package by feature/component, vertical slices. The correct approach is to package your code by feature or component, creating vertical slices that encompass all layers needed for a specific functionality. Explanation: user and product packages. Each package represents a distinct feature or component of the application. Subpackages within feature packages. The layers, domain, use case, adapter, infrastructure, UI, are now organized within each feature package. This keeps related code together. Domain contains the core business logic and entities for the feature. Use case contains the use cases that define the operations users can perform on the domain objects. Adapter contains the interface adapters that translate data between the use cases and the outside world, controllers, presenters. Infrastructure contains the implementation details of the frameworks and drivers, database access, external services. UI contains UI-specific components. Shared, optional for truly reusable code that is not specific to any single feature. Be very careful about adding things here, overuse can lead to a global, tightly coupled module. Think carefully if the code could be duplicated within the features/components instead. Benefits of packaging by features/component strong modularity changes to a feature are largely contained within its package. This reduces the ripple effect of changes and improves maintainability. Improved testability. You can easily test the functionality of a single feature by focusing on its package. Mocking and stubbing become simpler, as you only need to isolate the dependencies within the feature. Easier deployment. Features can be deployed independently, depending on your application architecture, allowing for faster releases and reduced risk. Microservices architectures often leverage this approach. Reduced coupling. Horizontal coupling across layers is minimized. Each layer within a feature only depends on layers within that feature or on well-defined interfaces from other features. Increased code reusability. Shared components can be extracted into a shared package, but use cautiously, as mentioned above. Better code organization. It's easier to understand the responsibilities of each feature/component and navigate the code base. Closer alignment with domain-driven design. DDD packaging by feature naturally aligns with DDD principles, as each package can represent a bounded context. Code example, illustrating the difference. Let's consider a simplified example of creating a user. Packaging by layer, bad. Problems. Changing the user entity, example adding a password field, requires modifications in create user use case, user repository JPA, and potentially user controller. Testing create user use case requires mocking the user repository interface and potentially setting up a database connection for the user repository JPA implementation. Deploying a change to the user creation feature requires deploying changes across multiple packages. Packaging by feature, good. Benefits. The user feature is encapsulated within the user package. Changes to the user entity are more likely to be confined to the user package. Testing create user use case only requires mocking the user repository interface within the user package. You can easily substitute a test-specific implementation. Deploying changes to the user creation feature primarily involves deploying changes within the user package. Key considerations and best practices. Naming conventions. Use clear and consistent naming conventions for packages and classes. Package visibility. Restrict visibility of classes and methods using access modifiers, example private, package private, to enforce encapsulation and prevent unintended dependencies. In Java, package private visibility means accessible only within the same package. This helps prevent layers within a feature from leaking their implementation details outside the feature. Interface-based programming. Use interfaces to decouple layers within each feature. For example, the create user use case should depend on the user repository interface rather than the concrete user repository JPA implementation. This allows you to easily swap out different implementations, example for testing, or to use a different database. Dependency injection. Use dependency injection to manage the dependencies between classes. This makes the code more testable and flexible. Frameworks like Spring or Goose can help with bounded contexts, DDD. If you are applying domain-driven design, DDD, align your package structure with bounded contexts. Each bounded context can have its own package, containing the domain models, use cases, and infrastructure related to that context. Feature toggles. Consider using feature toggles to enable or disable features at runtime. This allows you to deploy features to production without making them immediately available to users. Componentization and modularity. Go beyond basic features and think about your application in terms of reusable components. A component might be a set of related features that work together, or a reusable module that can be plugged into different parts of the application. Don't over-engineer. Start with a simple package structure and refactor as the application grows. Don't try to predict all the future requirements upfront. Code reviews. Conduct regular code reviews to ensure that the package structure is well maintained and that dependencies are not being introduced inappropriately. Example scenario: adding authentication. Let's see how packaging by feature makes adding authentication easier. Packaging by layer. Bad. Adding authentication requires changes across multiple layer packages. You'd need new entities, a new use case, potentially a new controller, and updates to the data layer. The ripple effect is significant. Packaging by feature. Good. You can create a new authentication package alongside user and product. This package would contain its own domain, use case, adapter, and infrastructure sub-packages, encapsulating all authentication-related logic. The existing features remain largely untouched, except for possibly integrating the authentication logic at the controller/presentation layer via some sort of filter/interceptor pattern. Conclusion. Packaging by feature or component is crucial for creating maintainable, testable, and independent software using clean architecture. Avoid the trap of packaging solely by layer, as it leads to tight horizontal coupling and undermines the benefits of modularity. Embrace the vertical slice approach to create a code base that is easier to understand, modify, and deploy, truly realizing the power of clean architecture. Remember, it's not just about how you structure your code within a layer, it's about how you organize the layers themselves into cohesive, feature-driven units. The modularity illusion is a seductive but ultimately damaging approach. Choose true modularity instead.